Telefonica Research. Actually, if you heard, one of the platinum sponsors for the conference is Telefonica, so we are a research center for that company here in Spain. And this work is actually a collaboration with people, a student from the Chinese Academy of Science, and some other people in Barcelona Media in Barcelona, Spain. However, it's even a bit more complicated than that, because this is the result of a Google Summer of Code project. So it was done partly with money from this open source project. And it's done in the context of a larger project, which is the CLAM framework. And actually, all of this is what I'm going to be explaining, hopefully will be clearer after the presentation. So because the CLAM framework, although it has been presented in many different conferences and publications, it might be not known here in the audience. It's a multimedia framework, so it's not so well known in the web community. It was given the ACM Best Award, Best Open Source Software Award for Multimedia in 2006. And I'm going to be explaining a little bit of the CLAM framework, and then I'm going to dive into a little bit more into details related to what we've done to the CLAM framework to do web identification, aggregation, and mashups of different levels of audio and music description, which is basically the content of our submission here. This is going to be a little bit of a roller coaster presentation because I'm going to be giving you a bunch of demos. Hopefully they're all going to work, but I'm going to get a little bit hacky here. So I understand that we're in the developers track, so you understand. You'll guess what I'm doing here, using sort of like latest versions of Linux kernel and drivers and so on. So chances that something fails are there. It worked an hour ago, but let's see. So about CLAM. It's a project that started almost 9 years ago. It's a framework which is mainly developed in ANSI C++, but we also use other languages like Python, for instance, for scripting. And we regularly compile and test on different platforms. And it's open source. You can Google it right now, and I think if you Google for CLAM, it will come up like second or third. Basically after the CLAM antivirus, which is also a very well-known open source project. And it specializes mostly in audio music, but it can work for applications that deal with general multimedia stuff, and we've done a few of those. It can work as a general application framework, which means that you're a developer, you actually get code and you compile your own application by either using its black box behavior, putting components together, or by extending it in any way. But you can also use it as a rapid prototyping environment, and I'll be doing a demo about that briefly. It's really object-oriented. When we say that, is that so one of the reasons we started this framework is I was teaching software engineering in the university, and we needed sort of like a testing environment where students would actually see how to use things like design patterns, architectural patterns, and so on, and in an environment that could also be doing real-time processing, and this was used for that. And actually, we've had a few publications related to pattern languages and domain-specific languages within the framework. So this is the picture of we used to explain the components that are in the framework. Basically, when somebody wants to build an application with CLAM, it can use two meta packages, which are, I think you can barely read, but here on the left there's a processing kernel, which is made of a bunch of repositories and a number of classes that define the infrastructure or the white box behavior framework. On the other hand, we have also a number of tools, and most of these tools offer things like platform abstraction. So you can do multimedia stuff without worrying whether you're going to be deploying it on Windows, Linux, or anything. Oops. On the infrastructure side, we have documented the infrastructure with what we call the 4MPS meta model, which means multimedia processing system meta model. And what that is like a semantic layer on top of graphical model of computation, which is known as data flow processing network. I'm not going to go into details, but basically it's a graph where nodes in the graph have a particular meaning and a particular behavior, and you can compute things like how schedulable a particular network is. And the interesting thing is that you get like a graphical metaphor of your system, whatever it is, where you have synchronous flow going from left to right, and you have another flow which is, we represent vertical lines from top to bottom, which is the control flow, and it's asynchronous, it's event-driven, and you can do very nice, sort of compose very nice applications by doing that. This is a detailed view of the behavior of one of those nodes in the network. And basically, not going into details, but also we have the horizontal synchronous flow and the event-driven control flow. Now, as I was saying before, that was the infrastructure, that's the white box behavior, that's what developers use, they compose with boxes and they create their application. But what those boxes are, which is the black box behavior, are a bunch of classes already ready to use, and some of them are processing classes and some others are data classes. And we have around 250 ready-to-use components that people can just grab and drop. And we have tools for platform abstraction, for XML persistency. So that's an interesting thing I'll be talking about later when we talk about description and metadata and open data and so on. Any processing data class that you actually put into CLAM, it has automatically built-in XML persistency, so that even the developer doesn't need to add a single line of code and he'll get automatic XML persistency. And I'm not going into details, but if you, I'm just going really quickly in the hope that if somebody is interested, you know where I am, so I'll gladly talk more about any of these things. We have also a visualization module for visualizing signals, data. And I want to mention that most of these things can be done only because CLAM is riding on top of a number of already existing libraries. So what we do is use many of those services and libraries and give them like a coherent framework where you can use a simple and graphical model to actually get them into an application. So applications that have been developed with CLAM, there are many. I just put a number of screenshots, and actually this one in the middle, which is a video, is the latest one, which was presented last week in the Linux Audio Developer Conference. I don't know if you can hear something, but it's, so this application has integrated the CLAM framework with the Blender 3D application for video development. So what we do is actually, and we're able to generate 3D audio scenes in which the audio is actually following the characters, and you can map and process in real-time 3D locations for 3D spatial audio. Okay, so you can use CLAM to build all these applications, but you can also use it to do some prototyping. And what you see here, and you'll see right now in the demo, is the CLAM. It's a visual builder, which we call the network editor, which you can use to really quickly, like in 5 minutes, build your own application and get it running without developing or writing a single line of code. And actually, that's what I'm going to show you right now. And this is where some of the fun begins. Okay. So, this is the network editor. So, if I open any of these categories, I find